A little bit of confusion. It was a few things that I don't think y'all were. It's not that you didn't know the material, you were just confused about it. So we're going to talk about the first thing I'm going to show you that I know some people had a question on was, all right, if we have a problem like this. All right, that's a parallelogram. It's kind of a funky parallelogram, but it's a parallelogram. All right, we're labeled 6. Actually, let me draw a better picture than this. I don't like that picture. I don't think y'all do either. We have a parallelogram like that. And Bryson, need you to pay attention, please. 13, 6. This was a problem that y'all had. If I have this problem right here, and then I have a question from one of the classmates. They said, what does this mean? And it had 4 labeled out right here. 4 feet. And it had 4 feet. So this right here stands for, anytime you see that right angle, it stands for a height. Our height has got to be, no matter how it's laid out here, a height of a parallelogram or a triangle has got to be from the base to the top. No matter where it is. From the base to the top. And so that's why one of your classmates, like I said, had a question. They said, well, how can this line right here, that's the height because it's 6 foot. No, it's not the height because it's diagonal. It's not directly from the base directly to the top. This right here is an altitude that we talked about the other day, and it's from the base to the top. So that's our height. So in order to do this problem, we use our formula. Area equals base times height. And we fill it in 13 times 4. So our area will be 52 feet squared. I'm going to draw another one, and this time, y'all are going to do it. So I'd like for you to take out a scratch sheet of paper and do this problem, please. You can do a scratch sheet. It doesn't have to be perfect. You can do a half sheet of paper. As long as it's quick. Alright, so actually we're going to do this one together. I'm sorry. If y'all did the next one. We'll do this one together. So, when we look at this problem, what do we first think? No, what do we first think? What are we looking for? Yeah, base times height. That's right. Alright, so Bryce, what's our base? Alright, now, what will be our height?
8.
So what do we do next? So answer that problem 2020. Alright, this one, I'm going to let y'all do this next one. We're going to change up here. A little different, just a little bit different type of problem. Alright, so somebody tell me, so I'm gonna let y'all do this one, but with it being drawn like this, which one is our base? What did we talk about the other day that it shows us our base? Alright, why, Bryce? Please speak up so everybody can hear you. No, but what did we talk about that was our base? It has to be our base. Even if they flip it, what's going to always be our base of a parallelogram? For the square root of... Yes.
For sixes, I can't be doing
For this problem, he's thinking too much about it. I'm not sitting here saying everything is technical. It's not the scale. Good job. Bryce said the straight lines. Anytime on a parallelogram, our base is always going to be the straight lines. It doesn't matter what type of problem it is. If it's a parallelogram and you know it's a parallelogram, you know your base is going to be the two straight lines. They're not going to be our diagonal slanted lines. All right, so if y'all would go ahead and do this problem by yourselves. And we'll go over it. Will, you understand everything about it? Good deal. You're done. All right, Bryce, you got it? All right. What's our formula, Bryce? All right. What is 9? How do we fill out? What's the next step?
12.
All right, Caleb. What's the answer?
72.
72. All right, good job. All right, so this concludes for today our lesson on parallelogram and triangles. Do y'all have any questions to wrap it up? Do you understand the process now? All right, good deal. That's good.